So 9-3 circles, I think you've seen some of this circle stuff before. Maybe some of it will be new. Let me know if you have questions as we go. Want to start out with this thing here, the number that shows up a lot in circles, pi. So Greek letter is that first writing. It's written P-I in English, pi. And I'm going to do a little squiggly equals that's about 3.14 ... So 3.14159 something, something, something. But so they have it out to like a million digits. There's some place you can go online if you want to. And you could type in a combination of numbers like your phone number. And it'll say, oh, these 7 numbers appear in order at this place in pi. Because they figured out to like a couple million digits or whatever. Yeah, so I can try to find it, or you could look and let us know where it is or something. But okay, so pi. I look at pi kind of like a God number. There's a couple of these numbers that just keep showing up in nature. One of them is pi. One you'll get in algebra class, algebra 2 class, this E. It's a natural number. They're both numbers that just kind of keep popping up in nature. You see them. All right, so moving on to something less exciting. So if you have the center of a circle, if you were talking to a first grader, you'd say it's the middle. Works for me. So it's the middle. So radius, the abbreviation for radius is a lowercase letter r. So a r there. Radius is the distance from anyone.
The middle or the center to the outside.
Perfect. So distance from the center to the outside of a circle. Later on in geometry class, you have to learn definitions for different shapes. And for a circle, the definition is something along the lines of all the points in a plane, so all the points in a flat surface that are a given distance, the radius, from a given point, the center. But if you want to label radius on your notes, you could take and draw a line from that center to the outside and then put a lowercase r by it. So, all right, next thing, moving on. Diameter is going to be lowercase letter d. Good. Because capital D stands for densities. They do a lowercase d there. And the diameter is going to be the distance across the circle through the center. So distance across the circle through the center. And like normal, I don't plan to ask you to write out these definitions, but when we talk about the diameter of a circle or the radius or the center, you should know what those things are. So I would pick any place on the edge of your circle, draw a straight line that goes through the center to the opposite side. So I got pretty close. And put a lowercase d by it for diameter. Now, how does the diameter relate to the radius? What do you have to do to the radius to get the diameter? Go for it. So the radius is only from the center to the outside. So the radius would be something like from here to here. So one radius there, another radius on the other side gives you the diameter. So the diameter is going to be 2 radii or 2 radiuses. So there's one equation. Or if we back up to the radius thing up above, we could say the radius equals, what do you do to the diameter to get the radius? Yep. So you could say radius equals d divided by 2. Or I'm going to put a 1/2 d in front. But d divided by 2 is the same as 1/2 times d. We okay for that?
Yep.
Then the next part, circumference. Circumference, we do a capital letter C, because lowercase c they use for the speed of light. Circumference is the distance. Anyone? Nice. Around the circle. I heard the word perimeter. It's exactly right. Circumference is really the perimeter of a circle, the distance around a circle. Fair enough? We have 2 equations for that. We could say capital C equals pi times the diameter. So capital C equals pi times diameter. Or the diameter, do you agree diameter is twice the radius?
Yeah.
So we could take this d and replace it with 2r, and you get the same thing, but usually they put numbers in front of variables. So the way they write it that second way is c equals 2 and then a pi and then a r. So c equals 2 pi r. I believe all these equations, at least these 2 equations for circumference, those are both on that bookmark that you have. So you could just look at your bookmark and get it from there instead of having to flip back to your notes. But you'll have it there. Up. This is up at the very top part under perimeter. So. All right, if we're looking for circumference of this bad boy here, do we use the first equation or the second equation?
Second.
Well, 8 is the radius. So then we go with the second one. So C equals 2 pi r. And the radius is 8. So we have 2 times pi times 8. I'm going to take and put some units in there. I'm going to maybe say inches and throw in inches there. So our final answer, is it going to be inches squared or is it just going to be inches? Just inches. Nice. Because it's a distance around, so it's not like an area. Area is always going to be square units. So we end up getting 2 times pi times 8. Our book a lot of times says use 3.14 for pi. I'd recommend just using the pi key, and your answers won't perfectly match up to the book, but might as well be more accurate in my mind. So if you have a calculator like this, kind of the normal Texas Instruments scientific one, the pi key is like 2 above the 7 and 1 to the left. So you could just take your calculator, and you actually don't even need to do multiplication. You could just do 2 and then your pi button and then your 8. Or you could do 2 times pi times 8. And you'll get 50.3 with a little bit of rounding. So 50.3. Mine says 50.2654, blah, 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 blah. You okay for that for circumference? If you have other calculators, you might need to hunt around a little bit to find pi, like the graphing calculators. It's up above the division key. So they have the exponent key above the division. You have to do second and then your exponent key to get it. So, move to the next page? Cool. So the next thing we've been talking about in this chapter is area. Area is capital letter A, because lowercase a is acceleration. I didn't really write down a definition. Area is like this kind of space inside a two-dimensional object, right? When I say space, it makes it sound like volume, but can I just leave it that way we know what area is? Yeah. Area for a circle, we only have really one equation typically. Area equals pi r squared. I suppose you could write a second one with putting a diameter divided by 2 or a 1/2 d for r, but typically if they give you the diameter, you just have to find the radius first. So, we okay for area equation? Jump to the example? So if we say area equals pi r squared, what do we put in for r? 5. Nice. It is tempting to do the 10, but the radius is just going to be half of that. Can I maybe throw some units in there? So I'm going to make them both centimeters. So radius is 5 centimeters. And then we need to go through and square that 5. Are we okay for the 5 centimeters, or should I show my work a little better? Okay. If you go back to the first page of your notes, we said radius is 1/2 d. That's the equation we have under radius. So if the diameter is 10, 1/2 times 10 gives me my 5. And if it's 10 centimeters, then the radius would be 5 centimeters. Is that a little better? Okay. And now you could take your calculator and hit that pi key and then do times 5 squared. Punch that in, you get 78.53, blah, blah, blah. So 78.5. And units would be, nice, centimeters squared. Because it's area, we're talking now how many of these little squares that are 1 centimeter by 1 centimeter fit inside the circle. Because the circle's curved, you'll have like partial squares here, but then other little parts elsewhere and so on. But we all right on the area stuff? That's the meat of the section. The last thing is really just 2 terms, inscribed and circumscribed. So inscribed. I just remember them this way. So it's the object inside the circle. So if we were to talk about a triangle that's inscribed in this circle, you just have to draw a triangle where the corners or the vertices touch the edges of the circle. So something like this here. And that's not the only triangle You know, you could have, so the blue is a totally good one you could take and have like a, one kind of like that, the red one. But so just basically the points of the triangle have to be inside the circle. We okay for that? So the very last part is the circumscribed. And I'm going to take and kind of do the same type of notation as what I did here, where I'll say the object and then the circle, and use this circumscribed part in there. So the object, if you want to kind of sound kind of cute, you could say it surrounds, C-I-R-R-O-U-N-D-S, the circle.
Oh,
Cute. Surrounds.
super cute.
So the object goes around the circle. The object surrounds, circumscribed, spelled the same. Okay. And now the drawing gets to be the hard part for me. So I'm going to take and I found I do better if I draw the object first. Maybe I should have put a circle and got out a ruler. Sorry, getting the low budget notes today. But so if that triangle were to circumscribe a circle or surround a circle, you have to try to do as close to a circular shape looking thing on the inside as we can. Ooh, did okay through the first bit. So if you have a nice perfect circle like mine, it might be easier if I had started with a circle and a straight edge. You could just take and then use your straight edge to find your pieces like so or something. So you should have done it that way, but something like that. You get the general idea at least? Yeah. Within the limits of your teacher's drawing ability. And I believe that's the last bit of the notes, right? Yep. Final comment though, make sure for each of these calculation things that you're doing, like this here, I'm looking for 3 steps. So to get full credit, looking for something like this. First step, write the equation with just the letters. Second step, put in the numbers. And if you want to do the A equals, that's even better. Third step, give me the answer. So like those, please do those 3 steps. I can give you full credit.